Hi, everybody. In this mini lecture, I'm going to discuss three common misconceptions about evolutionary theory. And I have these in here because sometimes you're going to run into people who are like, I don't believe in evolution. And of course, if they're saying, I don't believe in evolution, what they're really saying is that they don't believe that evolution can drive adaptations, that adaptations can drive speciation, um, because probably, I mean, I don't want to speak for everybody who says I don't believe in evolution, because to say I don't, if somebody says to you, I don't believe in evolution, it, the next question should be, can you define evolution? So, what's the definition of evolution? The definition of evolution is a change in gene frequency over time. So, for instance, let's say that we are on Long Island. Let's say that we're actually in Suffolk County, and that an airplane filled with people from Nigeria lands in the Islip Airport, in the MacArthur Airport. We have changed gene frequency over time. We went from having X number of genes that are commonly found in Nigeria to a whole bunch more because we just had, say, 300 people come here from Nigeria. The same would be true if we were talking about Sweden or Argentina. If we take a whole bunch of people from one place and we bring them to another place, we are changing gene frequency over time. So, um, that doesn't even make my three common misconceptions. But if you find somebody who says, I don't believe in evolution, your first question should be, can you even define it? And maybe leave out the even because you don't want to be a snot. And when they say whatever they say, you could say, no, evolution is defined as a change in gene frequency over time. And how can you not believe in that? That happens anytime you have immigrants come in. And I don't care if your immigrants are birds or people. Okay, so let's talk about three super common misunderstandings about evolutionary theory. Maybe you even have some of these yourself, because I find that even some graduate students can sometimes get hung up on some of these. The first misconception is that behavior is genetically determined. And we kind of talked about um, genes determining behavior when we talked about ethology. We talked about aggression in pit bulls or herding in cattle dogs, for example. But not all behavior is genetically determined. And if you are, and even things like aggression in pit bulls, if aggression was completely controlled by genes in pit bulls, then all pit bulls would be dangerous. But I'm sure any of you listening to that lecture were like, but I know a nice pit bull. Yeah, because it's only a trend, it isn't an absolute. Okay, so you already knew that not all behavior is controlled for by genes. One of the reasons for that is that most traits, height, skin color, how happy your baseline happiness level, those are all controlled for by a whole suite of traits, not by one trait. Even eye color is controlled for by 30 genes, not by one. There are some human traits that are controlled for by one gene, but they're few and far between. Whether I just went running, whether you have a widow's peak that's controlled for by one gene, for example. So this idea that all behavior is controlled for by genes is called genetic determinism. And we define genetic determinism as this idea that genes exclusively control behavior. Okay, that's bullshit. It's not true. Genes and environment both determine behavior. Both things are important. Both genes and environment control behavior. And like maybe you've heard of nature versus nurture. And even that question is kind of stupid because it sets up a fake dichotomy. You can either have nature on one side or nurture on the other side, nature being genes and nurture being environment. But the truth is that it's a combination of things. And if you think that genes are complicated because if you've got 30 genes controlling eye color, then how are you ever going to predict eye color? And we're actually pretty good at predicting eye color. Anybody who's made a Punnett square with grandparents' eye color knows this. But if you think genes are complicated, environment is super complicated because environment, there are feedback loops in the bodies of organisms that are so sophisticated we can't even imagine what they are, much less understand them exactly. So nature versus nurture, it's nature and nurture together. And you need a genetic component and you need an environmental component, even for skin color. Your skin color, your baseline skin color is controlled for by genes. I don't know how many, but it's probably in the hundreds, maybe thousands. But you can change the color of your skin with your environment. You go out into the sun, you're going to change your skin color. And it's super complicated because how much sun? Well, even that question, do you measure it in hours? Do you measure in photons per minute? Does it matter if you're on the equator versus if you're on the pole? If you're on the pole, does it matter if you're there in January or June? You can see that both of these things are complicated. There's this really great story about a professor who was doing research on I can never remember the difference between sociopaths and psychopaths, but whichever one it is, the cold-blooded killers, what the people who kill without remorse. And he was pretty sure that cold-blooded killers were missing a particular region in their brain, that a particular region in their brain did not light up. And so this guy went out to death row and he did MRIs of the brains of cold-blooded killers. And then he went and collected a whole bunch of MRIs from people who were not cold-blooded killers. He got his graduate students, his wife, his friends, himself. They all sat in an MRI machine so they could look at this particular region and see if it lit up or did not light up. And really funny story. So he's going through and he's looking at like essentially flashcards. He's like, yep, this one looks like a cold-blooded killer. And he looked on the back. Yep, it's a killer. And this one looks like a control. And he flips it and looks on the back. Yep, this one is a control. And he finds one that looks like a cold-blooded killer, but he flips it over and it says control. And his first thought, as is any scientist who's worked in lab, is that it was a mistake, that somebody labeled something incorrectly. And so it was a double blind, so he didn't know who it was. So he pulls off the label and sees who the person was. And it turned out to be not somebody on death row, but himself. He had the brain structure of a cold-blooded killer. And he freaked out and he went to his mom and he said, Mom, what do you think about this? I have the brain of a cold-blooded killer. And the mom sort of laughed and said, yeah, well, I'm not too surprised. It turns out that your great-grandfather was somebody like Jesse James, somebody who just went and cold-bloodedly killed a whole bunch of people. So he was a descendant of a cold-blooded killer. Okay, so that story was on NPR. And it's a really funny story. You guys can look it up. I don't know the name, but you and like some of the details are hazy there, but you could look it up anyway. And when I first heard that story, it stopped there because his take-home message was that even though he had the genes that led him to potentially be a cold-blooded killer, he wasn't. He in fact he was married, he had kids, he had a job, and in this interview, he said, yeah, well, my environment was supportive and I had two parents. I didn't experience war. I was never very hungry. Nothing bad ever happened to me. And so the cold-blooded killer in him was never triggered. And in fact, instead, he was, a model person in the community. Okay. I heard another interview with this guy on the moth. Okay, wait, let me stop before I talk about the moth. The real point that he was making is that genes and environment both drive the outcome. So you're not going to be a cold-blooded killer. You probably, even if you have the genes to be a cold-blooded killer, you may not be a cold-blooded killer if you have a supportive non-stressful environment, right? You got a stable household, you've got food on the table, you're not living in Beirut, um, or Myanmar or any of those other war-torn places. Um, could be a normal person. Okay, then on the moth. So this guy was obsessed with the fact that he was a cold-blooded killer. And so he goes to his wife and he says, "Do I seem weird to you?" And she's like, "Yeah, honey, you are a little distant sometime. Like, you always want us to celebrate your birthday, but you don't want to celebrate any others. And do you remember when your best friend died and he went to the work in the lab instead of to his funeral?" And the kids said to him, when he asked his kids, the kids said, "Dad, you don't even care about our birthdays. Like, you don't care. Like, you're a good dad and everything, but you're not going to go that extra emotional mile." And he was Catholic or something like that. And he asked his priest, and the priest says, "You know, you always tried really hard to be good. You had to really focus on being a good person. And most people were just, they're either good and they just trusted that and they go on." So clearly, um, even though he had the genetics to be a cold-blooded killer and he wasn't, clearly he was outside the bell curve for normal behavior. So other things besides being a cold-blooded killer, other things that are like that are alcoholism. So alcoholism can be distilled down to about 20 genes. It has been studied in populations where a lot of people have the genes that determine alcoholism. Some Native American tribes out west, for example. But just because you have the genes doesn't mean that you're going to get the disease of alcoholism, right? You have to experience something in your environment that has to trigger it. And that's true even for things that aren't related to behavior like breast cancer. So even if you have both BRCA1 and BRCA2, there's only an 85% chance that you're going to get breast cancer. So genetic determinism is something that people like to lean on, but it's not true. So let that idea go. Okay, second misconception about evolutionary theory. If it's evolutionary, if it's got an evolutionary basis, we can't change it. Okay, also bullshit. For this particular example, I'd like to give an example from this 1951 movie with Humphrey Bogart and Katharine Hepburn called The African Queen. And in The African Queen, and Catherine is supposed to be the daughter of a missionary family in the Congo, and this is World War One. Yeah, World War One, and Humphrey Bogart is supposed to go out there. I think it's supposed to be World War One. It's 1951 is World War Two, but I think the movie is set in World War One. And Humphrey Bogart is the captain of a ship called the African Queen, and his job is to go up the river and rescue the missionaries. And of course, he gets in, the missionaries are like, "Pish posh, we don't want to be rescued." But then her parents get killed, and she decides to go with him. And so they hate each other because he's rough and tumble and he drinks and smokes and swears, and she's the daughter of a missionary family. She's a missionary. And so they're having a heart to heart on the African Queen on their way home. And Humphrey says, "A man takes a drop too much once in a while. It's only human nature." And she says, "Nature, Mr. Allnut, is what we are put on this world to rise above." And her big point really is that you have a choice, right? You might have a genetic predisposition to fill in the blank, any number of horrible things. Have that 14th drink, sleep with somebody who's not your spouse, whatever you want to come up with. And she's just saying, no, take responsibility for your own behavior. And evolutionary psychologists, so if you want to see a psychologist who leans heavily into evolutionary theory, they will use this to help you understand your predispositions and then help you make choices to um, um, rise higher than that. Okay, so the real point I want to make here is awareness of the cause of a behavior may allow you to modify it. Okay. And the last idea that the last misconception I want to pass by you is this idea that current mechanisms, current traits, current behaviors are optimally designed. Okay, so what does that mean? That means that the behavior of a shark is the perfect behavior for a shark that lives in its environment. Right. So if you are evolved to cooperate, it's because cooperation is a really good coping mechanism to get more of your genes into the next generation. Okay. So your adaptations, the mechanisms that you use to cope with your environment, they're going to be a really good fit for your environment if your environment has not changed in, say, 20 generations. So things like horseshoe crabs, we can find horseshoe crab skeletons that are gazillion years old that look just like horseshoe crabs because the world that the horseshoe crabs live in up until the last 20 years has been non-changing for literally millions of years. The same is true for coral. The same is true for sharks. Unchanging world leads to adaptations that suit their environment. However, if you are living in a world that's under constant change, then your traits that you inherited from your parents, who inherited from their parents, are probably suited to whatever the environment looked like a handful of generations in the past. So, for instance, if you look at those New York City rats raiding the garbage there, do you think that ancestral rats had garbage to raid that came in plastic bags? No. So rats might have a lot of traits that make them suitable um, to their environment, but they're probably not perfectly suited to the food that they're getting in that garbage sack. So, for instance, if you want the healthiest rat, they're probably not eating leftover junk food, but these rats are eating leftover junk food, and their physiology is not adapted to that. Okay, so one of the classic examples of environment, a misfit between environment and physiology or adaptations has to do with human weight. So if you think about the world that human ancestors lived in, even as recently as World War II, which is the 1940s, we come from an environment where calories are restricted. We don't have um, unlimited access to calories. Currently, we have unlimited access to calories. And even though you will hear about starvation in the United States and kids going hungry, one of the markers of being poor is being fat. Just think about that. Fat people are more likely to be poor, and poor people are more likely to be fat because the people who are overweight have one of two things happening to them. They're living in a food desert, so where they can't get any fresh food and they're getting all their food from, say, a bodega, which their idea of fruits and vegetables are come in cans and are expensive. And they're working a lot, so they don't have time to exercise. So they're eating Cheetos and things out of cans, and they're not working, which leads to being overweight. But if you took, and so not their metabolism, everybody's metabolism is adapted to saving. Why do we have high cholesterol? Because our bodies are really good at storing cholesterol, because we need cholesterol if you're starved, because then you catabolize that cholesterol and you get energy from it. If you live in an environment where you're storing all that cholesterol, but you're never metabolizing it because you're never hungry enough to need it, then you're going to get heart disease, right? So there's a miscommunication between where what our environment looks like now. The cheapest food is Cheetos, to what kind of environment our ancestors lived in, a place where Cheetos just don't exist and that you had to work pretty hard for every calorie that you got. All right, we've got one more lecture in this series, and I will see you for that one.